To be a successful data analyst, you need to have a holistic view of how to conduct your analyses. As much as you must have a solid understanding of how the technical tools can perform the calculations and visualizations you need, you must be guided by logic and intuition to solve your business tasks successfully. In other words, let your analytical thinking lead the way. There are two reasons to do this. The first one is that doing so will preserve your analytical process clear, which is very important. The second one is that being an analyst rather than just a coder will help you a great deal while searching for technical tools that can deliver answers to your analytical questions. You will also better understand how and why a given tool has been created in a certain way. That said, you must have a mindset that allows you to use a variety of tools to achieve your analytic goals. Sometimes, this might mean combining work on different software programs, but in other cases, it could be working with several Python packages simultaneously. On that note, let's talk about NumPy. This is the fundamental package for scientific computing with Python. Its name stems from the words numeric and Python. Using it gets you as close as possible to straight mathematics, and it does so in a very efficient way, in the sense that it allows you to intuitively perform highly complex mathematical computations fast. Just to give you an idea, at the core of the NumPy package is the IndArray object. Conceptually, it may correspond to such mathematical objects as scalars, vectors, and matrices. Due to its structure and high performance, it allows you to apply advanced mathematical stations on large numbers of data, something which Python's built-in sequences are insufficient for. That's why you will most certainly need this library in your analysis. Pandas is another Python library that is important to look at. It has been built on NumPy, and its name stems from the phrase panel data. The latter is a term used in econometrics for datasets, including multiple observations over multiple periods of time. To put it simply, this term is used for a certain type of data tables. In terms of its applicability, Pandas is a powerful Python data analysis toolkit. It is used not only for numeric data, but also for text, Boolean, and more. The fact that it has been built on NumPy means that Pandas needs the computational power and abilities of NumPy to perform its computations. However, since it is primarily a data analysis toolkit, Pandas operates with the data in an easy-to-use way, allowing you to focus more on your analytic task and less on the underlying mathematical computations. Furthermore, two data structures are at the core of Pandas, the series and the data frame objects. They correspond to a single and multiple column data, respectively. These objects store the data we're interested in and allow us to apply a myriad of manipulations on it. Interestingly, although from a programming perspective, you could say that NumPy comes first and Pandas second, in the practice of a data analyst, it's usually the other way around. In other words, if you have data that is not only numerical, but also non-numerical, and that needs a lot of cleaning and improvements, you'd normally use Pandas to import the data into Python. It's because Pandas allows you to easily manipulate data until you've obtained a clean and well-organized dataset that is ready for pre-processing. For work that comprises these processes, Python and Pandas could be sufficient to complete the entire job. Once you've done that, your dataset is ready for serious mathematical computations. And it is then that you may want to take advantage of the NumPy library to thoroughly pre-process your data. Being aware of everything we've said so far, you can now see why NumPy and Pandas are both so famous and come with Anaconda. That is to say, by installing the Anaconda distribution successfully, you don't just have Python and Jupyter at your disposal. You will also have the NumPy and Pandas packages installed and ready for use. However, since each one of them represents a huge amount of pre-written code for specific use, the latter two being data analysis and mathematical computations, they will not be automatically executed for you once you open a Jupyter Notebook document. In other words, they are not part of the standard Python library, which is loaded every time you start a new Jupyter Notebook document. To use these libraries, you must manually import them at the beginning of your document. How to do that? To import the NumPy package, you need to type import NumPy as np. Please notice that we've used the alias np, written in small letters, as the convention requires us to. This means that when we are referring to NumPy later in our code, we can only use np, and we won't need to use the entire name, NumPy. Although you might think writing 3 letters less doesn't hurt, think of the fact that you might actually need to use this package hundreds or even thousands of times in your code. Then it would make more sense to use NP instead of NumPy, right? Also, let's not overlook the fact that using NP has been the convention for years already, so it is best to stick to it in your work. Good. Once you've typed import NumPy as NP, remember that it is crucial to execute this code cell. Unless you do that, Jupyter will not understand that you are willing to use the relevant pre-written code. So, run this cell, and you can take advantage of all the tools that NumPy has prepared for you. Besides, you must know that oftentimes there is a discrepancy between the latest version of a package available out there and the version you have with your Anaconda or whatever Python software you are using. Usually, when working professionally, you need to ensure that the package you will be working with is up to date. To do that, you need to always upgrade it to its latest version. First, let's check the version of NumPy we are having. To do that, you can execute np dot twice the underscore sign version twice the underscore sign again. As you can see, the version we are having is 1.18.1. To upgrade the NumPy package to its latest version, Windows users need to go to Anaconda prompt, while Mac users to terminal and execute pip install numpy -- upgrade. This is a process that may take a couple of minutes, but when done, you will be basically ready to work with the latest version of NumPy. To check that, you can go back to your Jupyter Notebook document, restart your kernel, import NumPy again, and then check its version by once more executing np dot underscore twice version underscore twice. You can see that we have just moved to the newest version of NumPy with respect to the date in which this video has been recorded. Right. We just ensured that we know how to set up the latest version of a package we need. Particularly for NumPy, we'll do this operation once more later in the course when we start studying the package in detail. As a matter of fact, you can always use this trick when you learn that a certain package you are using has been recently upgraded. If you're uncertain whether you're using the latest version, you can always go to pypy.org and type in the name of the package. In addition, you can check out the release history for a timeline of all the recent upgrades. Identically, we can upgrade and import the pandas library too. In a Jupyter Notebook document, type and execute import pandas as PD. Here, PD is the conventional name used for this library. After executing PD dot underscore twice version underscore twice again, you can see that the current version of pandas is 1.04. To upgrade to its latest version, you can go to Anaconda prompt and execute pip install pandas -- upgrade. Please remember that this step is identical for Mac users who can use terminal. After you've done that, you can go back to your Jupyter Notebook document, restart the kernel, import pandas again, and execute PD dot twice the underscore sign version twice the underscore sign again to verify that you are ready to work with the newest version of pandas, comparing to the date in which this video has been recorded. Therefore, remember to import such libraries at the beginning of your code, since this is the only way to take advantage of the benefits they offer within a certain Jupyter Notebook document. When you do that, you'll be good to go. To conclude, keep in mind that throughout the course, we offer a unique approach to teaching NumPy and pandas. We will show you that the two packages can go hand in hand when solving analytical tasks. We choose to do that as opposed to trying to introduce multiple raw technical and programming concepts separately, without explicitly making clear why you would need them later in your work. After all, we are advocates of conducting analyses with clear ideas in mind. Awesome! Let's see what's next.